What's up, everybody? In this video, we're going to explore how we can use AI as a prototyping tool. In the previous lesson involving AI generating code, you should be able to see how AI can program much faster than you can. It can also add more advanced concepts and give you working code. In my opinion, this gives you more time to build, test, and iterate. I want to explore this concept through an example. I have a project where I want to make a logic puzzle for an escape room. I found a 3D design for a flight simulator throttle that uses potentiometers to measure the position of the lever. I plan to use those and have them set at various positions. Next, I want to have two NeoPixel strips. One NeoPixel strip displays the solution and the other displays the logic as the player changes the values of the levers. The goal for them is to match the colors shown on the NeoPixel strips. I want to see how well I can use AI to write the code for the puzzle. Start off by logging into Tinkercad using your course username. Select Circuits in the menu under your designs. You will see our basic setup circuit that we made in a previous video. Hover over the circuit and click on the gear in the top right-hand corner, select Duplicate. Click the name of the circuit in the top left corner and change the name to Programming with AI-Lever Logic Puzzle. Next, I need 4 potentiometers and a NeoPixel strip. Drag 4 potentiometers to your breadboard. Connect terminal 1 on all potentiometers to ground and terminal 2 on your potentiometer to power. Connect the wiper pins of the potentiometers to A0, A1, A2, and A3. Next, we will add NeoPixels to display the colors. One of the cool things about NeoPixels is the ability to chain them together to create custom LED visualizations. For my circuit, I want to have 2 rows of 4 NeoPixels. I'm going to make 2 separate NeoPixel strips. Drag a single NeoPixel from the components to the artboard. Rotate it so the in is facing the Arduino. Each NeoPixel has a power, ground, in, and out. You connect the wires from one another to make a chain. Copy and paste the NeoPixels so you have 2 rows of 4 NeoPixels. Connect the power and ground on each to one another and then to the breadboard. Connect the in to the out on each. For the last in, connect each to pins 2 and 3. Great, now our circuit is complete. Click on the Code tab and ensure the text drop-down is selected. Fill out the information in the header of our code. Update the program name and description. The program name is Programming with AI-Lever Logic Puzzle, and the description is a sketch where we create a logic puzzle using 4 potentiometers. The goal is to match the colors on 2 NeoPixel strips. Select the code and copy it. Next, we're going to prompt the AI. I have a fairly complex prompt that I'm going to use. My prompt is, use the code provided as a template. Write Arduino code that is a logic puzzle. The puzzle uses 4 potentiometers and displays the solution on a NeoPixel strip. There should be 2 NeoPixel strips. Each strip has 4 pixels. One strip that shows the solution on the bottom connected to pin 2. The other NeoPixel strip changes when you change the values of the potentiometers, which is on the top and connected to pin 3. A person solves the puzzle when the top NeoPixel strip matches the bottom NeoPixel strip. The potentiometers are connected to A0, A1, A2, and A3. Paste the code below the prompt. I have pasted the prompt in the description of the video. You can make adjustments to the prompt as you see fit. Copy and paste the code into Tinkercad. Click Start Simulation. Try moving the potentiometers. As you move them, you should see the top color changing. Try and match it with the bottom. If you are successful, it should blink. I've tested this out, and I get it to what I think is matching, but isn't showing me that I'm successful. Also, there's nothing printing to the serial monitor. Let's add some serial statements to see if we can debug the value of the top and the bottom. Respond with the following prompt. Add serial statements to show the value of the potentiometers and the value of the solution to make it easier to debug. Copy and paste the code into Tinkercad. Click Start Simulation. Try moving the potentiometers. The debug statements aren't helping too much. Let's look at how the potentiometers and the LEDs interact. There are some issues with this puzzle. What we are asking an individual to do is match the colors. An exact match is too difficult as it requires the input to be too precise. Let's simplify the puzzle. Let's map the potentiometers to a range. In my case, I decided to have 4 different ranges someone could put the lever. Respond with the following prompt. Each potentiometer is connected to a lever. The levers can have a value of 1, 2, 3, or 4. Copy and paste the code into Tinkercad. Click Start Simulation. Try moving the potentiometers and look at the serial statements. Now, we can move the potentiometers to match the colors. When they match, we see a celebratory animation. Cool! As an exercise and lesson, this is a good place to stop. If I were to move forward with the design, there are some things to consider. I'm asking individuals to match color. As such, I need to accommodate for individuals that are colorblind. A series of prompts to check and provide new code would be good. I could also prompt to make the puzzle more difficult by making a logic puzzle with hints. At the end of this video, you should be able to create a basic puzzle that uses potentiometers and NeoPixels using AI.